Okay, now this is some interesting data that I haven't really shown before. So this is the effects on colony survival. So what were the factors in our experiment that actually predicted that a colony would or would not survive at any given moment in time? This is data from 2024. We looked at a number of factors. They're not all included on here. I just wanted to include some of the ones that people would think about including. So the first one that I want to draw your attention to is the alcohol wash levels. So that's the Varroa load in the adult bee population. So sampled using alcohol wash method. It's fairly well established that high levels of Varroa do lead to poorer colony outcomes. Like that's sort of our whole thing. Yeah. But here we see that confirmation. So alcohol wash numbers, the level of Varroa as measured that way was negatively correlated with colony outcomes. So colonies were more likely to die if they had higher Varroa loads. No big surprise there.
No big surprise.
No big surprise. But there were some things that were kind of surprising. So we looked at weight, so the weight of the colonies and how well that predicted survival, and actually it didn't. So the weight of the colony wasn't related to whether or not the colony would survive. And in fact, this is about as non-existent of an effect as you could possibly have in science. It's very not related. Things that were related that are probably also not surprising, adult population. So as adult population increased, the rate of survival of those colonies also increased. And same thing was true for the amount of capped brood in colonies. So as the level of capped brood in colonies increased, there was greater survival for those colonies. So this is across time. So it's a little bit coarse data because this includes everything from spring to fall and everything in between.
Right.
Now, really surprising from our perspective and maybe not looking back through the literature is that deformed wing virus and the two strains that we were really focused on, A and B, we actually tested for C, but we didn't see it anywhere. These weren't related to survival in a straightforward way. And people often talk about the synergistic effect between Varroa and viruses. Mm-hmm. And that really does seem to be what's happening here. So DWVA, which that is discussed a lot in the recent USDA preprint that was released. So on the colony losses that happened last year in the US. This is implicated. So DWVA was implicated in those colony losses along with resistance to amitraz. But whereas DWVA in their data was highly correlated with colony losses, it actually wasn't in our data. And one of the reasons for that was because that was not the strain that we detected the most. In fact, we had trouble detecting it. We saw it a little bit. It has been historically understood as the strain that is more virulent, mm-hmm. But it's also been gradually replaced as time has gone on with DWVB, which is more tightly related to Varroa infestations, but seems to be less virulent. So it seems to be easier for the colonies to manage. So in our studies, even though we were looking at adult workers, adult drones, pupa of drones and workers, and ones that were and weren't infested with Varroa, in none of those populations did DWVA actually predict poor survival.
So Heather, this is a very interesting data set, but our lab here in Canada isn't equipped to do virus research. Can you tell us a little bit how you went about having the analysis done?
Sure. So it was a fortuitous meeting of my collaborator, Dr. Zach Bates, and we met at a conference.
Oh, yes.
And we started discussing some of these ideas about viruses. And he mentioned that he might have some access to some funding. So we actually applied to the North Dakota Department of Agriculture. They had a grant that was available. So we were able to get some money to be able to do this, the PCR analysis for the virus, which can be quite expensive. So right. That's not to say that there aren't labs in Canada that would do this. We just happen to have money for this. So
right. Well, it's great to cooperate with people in North Dakota. That's a big beekeeping state. And so what happened was you collected the sample, your team here in Ontario collected the samples, and then you would send them off to Dr. Zach Bateson in North Dakota, and they independently, blindly would conduct their analysis and then send you back the data, and you would share the data with them.
Yep.
And you have this very interesting is looking at 7 different metrics you're using to see what effects each one of those have on colony survival. So our thanks to Dr. Zach Bateson and the North Dakota National Agriculture Genotyping Center, and hope to work with them again in the future.
Yeah, he's been a great collaborator. And in fact, we actually analyzed far more parameters than this. This is just some of the more interesting ones. We were very careful because we're both industry scientists, so we wanted to remove any real or perceived conflict of interest. Right. So we always worked blind. So we would gather the field data and send him the samples blind. He would send us back stuff blind. And we also both ran independent analyses on the data. Okay. And we did that blind. So we really tried to make it as objective as we possibly could. Perfect. And by blind, I mean that the treatment groups weren't easily identifiable to us when we ran those analyses. So we couldn't accidentally or on purpose bias ourselves for the result. Very good. Very important part of science. Yeah. So I wanted to finally just to end up talking here about deformed wing virus type B, which was the one that the dominant strain in our samples. And in talking to Dr. Bateson, he mentioned that that's the trend that he's seeing with their samples as well, is that is becoming the dominant. And that's actually out there in the published literature as well. Okay. Again, historically, we have felt, and there's data to support, the notion that DWVB seems to be less virulent, so easier for the bees to handle. So we found 2 really interesting relationships between deformed wing virus B levels in the colony and survival. The first is in unparasitized worker broods. So in worker brood that didn't have Varroa in it. Mm-hmm. We took those out, and in that case, the level of deformed wing virus B, which is in some ways sort of the background level of deformed wing virus, because this wasn't directly transmitted by a Varroa in the cell, that negatively correlated with survival. So the higher the background level of deformed wing virus, it seems, the greater the chance that the colony wasn't going to do very well. Okay. That's not that surprising. The one that was really surprising, though, is this. So if we look at the level of deformed wing virus in adults, that actually positively correlates with colony survival. So the higher levels that the adult workers had, the better that the colony survived. And that might be due to a couple factors. One of them is survivorship bias. So survivorship bias is when the only things that you count are the things that made it that far in the investigation to count. Everything else died before that. Right. That's why people talk about these old appliances like lasting forever. Well, they have one example, which is this old fridge that managed to survive. So then they use that as their starting point to say, that old appliances are better. Sure. When maybe it's not true. So the survivorship bias could be an explanation. Another potential explanation is that the colonies that had genetics that allowed them to cope with the virus better were stronger and allowed individual bees within that colony to have higher levels of virus before it negatively impacted them. So the higher levels might actually be correlated, not causative. So in that case, it's not the higher levels of virus are causing the colonies to survive longer. They're just able to cope with it better. Right. So those are possible explanations. We have to test that.
And that could relate back to breeding programs. Yeah. Like if we're looking at bees more able to handle Varroa loads, it may be because those bees are more able to handle virus loads. Yes. So this is an interesting approach to maybe going forward for the research community to consider. Hello beekeepers, is your Varroa IPM working for you? We have created a 5-part series to help beekeepers answer that question. In this 5-part series, we'll be discussing the following topics: threshold versus goal-driven IPM, protecting populations, where are your Varroa and viruses, and the focus on fall treatment. Thanks for watching another episode of Behind the Hive. Please feel free to add your questions or concerns in the comment section. Give us a like if you're enjoying these videos, and we look forward to being with you again in the future.